Air quality matters, inside our buildings and out. We already have many of the tools we need to make a difference. The conversations we have and how we share this knowledge is key. I'm Simon Jones, and this is episode 35 of the Air Quality Matters podcast. Coming up, a conversation with Brad Prezant. He is a public health and occupational health scientist with an epidemiology and public health perspective. He works primarily as a consultant, with additional experience as a university-based research scientist. He has assessed indoor air quality and ventilation, as well as mould and moisture in airports, hospitals, public buildings and schools since 1979. He is one of 50 people worldwide with the designation Certified Industrial Hygienist with a subspecialty in indoor air quality. He is an author of numerous professional documents published by professional societies addressing indoor mould, including a co-author of the Bioaerosols chapter in the Aerosols Handbook, and editor of the first edition of the Recognition, Evaluation and Control of Indoor Mould published by the AIHA. He is the author of AirAH's guidance document for schools, COVID-19 ventilation optimization, and was a contributor to the Harvard School of Public Health document on airborne transmission of COVID-19 in airports. He's a frequent speaker on topics related to indoor air quality, bushfire smoke, indoor moisture and mould, asbestos, and even meth labs. Although I've been following Brad for years, we finally got to meet in Copenhagen last year, and now we've got him on the podcast. I've been really keen to talk to him and bring the occupational health and hygiene lens to our discussions. And what a great guest to talk about the subject. We talked about the voice of this discipline in indoor air quality, building assessments, and even meth labs. I think you'll enjoy this discussion. Thanks for listening as always. Do check out the sponsors in the show notes and at airqualitymatters.net. This is a conversation with Brad Prezant. Trying to understand what occupational hygiene is in the built environment and its place in this air quality conversation that we have. Because I get a sense personally that it's not as front and center as perhaps it could be or should be in a lot of the conversations we're having around healthy buildings. And occupational hygiene or its various derivatives of that worldwide don't seem to be there as much as I'd expect. Maybe if you could explain, give us the 101 on really what your sense of what occupational hygiene is. And you're quite unique in that you're one of the few registered air quality occupational hygienists as well. So I think you have a very specific perspective on this.
Yeah, I mean, when, industrial environments were very prominent in America, we're not occupational hygienists, we're industrial hygienists. And that's really the root of the profession. So talking about exposures at work to toxic chemicals. And of course, in the third world, in many countries, those exposures are very significant. And occasionally they pop up in the first world, like the epidemic of silica-related problems that we've had. I think you're dealing with those as well, even the legacy of asbestos. So the issue of hazards at work has always been generally very pronounced because of all the toxic chemicals and substances that we work with. I think when I first entered the profession, there really was little interest in the built environment, and there was little interest in the office environment. In fact, I remember I graduated from the University of Washington with a degree in public health, and I was working in that department. And, if I was interested in the office workers in a industrial facility and the air quality that they might have been exposed to, I think the general attitude was, why are you paying attention to the people in the office? If you want to see real hazards, go out onto the factory floor. And that's where we've got the real problems. So I think initially the profession was not at all interested in the built environment or even the non-occupational environment, or at least not the non-industrial environment. But if you think about the kinds of training that an occupational hygienist receives, it's always been a very interdisciplinary type of a program. So you need to have a grounding in the basics of health. You need to understand things like occupational lung disease, epidemiology. The required courses covered all the public health disciplines. So you develop that public health attitude. And then you're also taking classes in designing local exhaust ventilation systems for plating tanks or joinery equipment. How do you evacuate the dust that a table saw produces versus a bandsaw versus a sander? And actually literally designing in the same way a mechanical engineer would design the supply of air to a space. You're designing the removal of air from that type of an environment. So you have to learn the same fluid dynamics. You have to learn the same air movement issues, fan curves, all the stuff that mechanical engineers learn to do when they do HVAC. You're learning, but the focus isn't so much on delivering the air, it's on removing the air efficiently with minimum frictional losses and with performance. You have to achieve a certain capture velocity in order to capture that dust, and you need to design the system accordingly. So as an occupational hygienist, you start out with a foundation in both engineering and health by virtue of the training that you receive. Not all hygienists in all countries receive that type of a background, but when I went through a graduate program in public health, that was considered to be a part of it. And the instructor who was teaching us the ventilation aspects was designing the hoods, or at least the hangars, to paint Boeing's airplanes in Seattle and evacuate the vapors from the solvents used in the paints. Of course, those have become much more focused on aqueous paints over the years, but at the time, it was all very intense, heavy solvent exposures that those workers might have experienced. So I think in some ways, as you pointed out, maybe occupational hygienists are not a big part of the conversation, but they ought to be, because they have the right training, background, and focus to understand issues of the built environment, which is also an extremely interdisciplinary area of practice. So understanding health, understanding exposure assessment, whether it's particles, vapors, whatever, understanding all of the issues related to building science, the physics, air movement, all of that stuff is stuff that a hygienist has to understand. The talk I gave recently began with a very classic, like Occupational Hygiene 101 graphic showing a source, a pathway, and a receiver. And in the industrial environment, the source may be a plating tank, and the pathway is the person's head having to be in between the plating tank and the exhaust, because that's what the job requires or whatever. But we have that same issue if we're talking about a building and air is moving through that building, perhaps ascending an elevator shaft and coming out a few floors above. That concept of source, path, receiver, and then the intervention strategies. You could reduce the source strength. You could interrupt the pathway. You could move the receiver. All of those principles are really going to be carrying through to indoor air quality issues. And,
interesting.
The early issues of indoor air quality were focused on quote unquote sick buildings. And at that time, if you had a sick building, who do you call? Nobody would have called the mechanical engineer because they saw it as a health issue. People having symptoms. Well, if you have symptoms at work, you call an occupational hygienist because, in theory, it has something to do with the nature of the work or the contaminants produced. So I think we were drawn into the field somewhat, sucked in and pulled in rather than beginning in that area. I found it to be quite interesting because it was very different than the other types of work that occupational hygienists do, which is generally pretty cookie cutter. If you're talking about most jurisdictions, you've got a list of 200 or 300 substances, mostly chemicals. They have a permissible exposure limit or workplace exposure limit, some type of a threshold value that's promulgated in law. And in theory, you're working with welding fumes or xylene or toluene or whatever substance it might be. You look at the chart, you say, okay, a worker could be exposed to so much for an 8-hour workday. You sample, and they're either above or below that
Yeah.
level. So that's very cookie cutter kind of a thing. But the moment I was asked to evaluate an office building because people were getting sick, it was definitely not cookie cutter. It was far more complex. If you think of a single exposure in an industrial workplace, it's a very clear cut situation. But what I learned as I began doing these assessments is that there was often not a single cause or a single agent. There was many contributing causes to the problem. And the analogy that I like to use to explain that phenomenon is the one of a cup that's sitting on the table, a glass beaker, perhaps, that's 500 mils in volume. And, you pour in 150 mils of one liquid, and then you pour in 150 mils of another liquid, and then you pour in 150 mils of a third, and then 150 mils of the fourth. And well, now that's at 700, and it's a 500 mil beaker, so you've got a little bit running off onto the table. So which of the beakers is the cause of the problem? It's the contributing cause of 4 separate issues, each of which is adding, and which in some might be the problem. And the symptoms you're seeing is the water running on the table. It's the workers complaining. So often I found there was not a single cause or not a single source or not a single agent, but that it was the contribution of many separate factors, all of which were impacting on the health concern or the symptoms that people were experiencing. So then your intervention strategy would really be a little bit different. You would say, okay, maybe I'll try and get the one that's producing the largest volume into the beaker. If I've got a 500 mil beaker and I've got one that's throwing in 300, I could live with the others each throwing in 100 if I can get rid of that 300 one. So that your strategy then becomes not so much to completely eliminate the sources, but to simply try and pick off the one that's having the greatest contribution. And what I found as I did these assessments, particularly early in my career, is that the ventilation system was often one of the contributing causes. It wasn't the exclusive contributing cause. It was one of several, but that it seemed to have a disproportionate effect on what was happening, and that it might be the one that was easiest to intervene and control. So that's how I became much more involved with ventilation issues. Having had the background and the basic understanding of air movement and frictional losses and all the stuff you have to do in order to design the local exhaust ventilation
Yeah.
system, suddenly I had never even dealt with the idea of delivering the air. It was like, hey, if you're pulling out all this air, make sure you introduce makeup air. And if you're costing it, make sure you allow for the heating or cooling of that air into the space. And that was about it. And suddenly, I had to teach myself, and I had a number of mentors and people I worked with who helped me learn all about the supply side and all the things that could go wrong in that dynamic balance of supply, return, delivery, exhaust, etc. So I think, getting back to our original premise of occupational hygienists and why we should have a voice in this and why we're involved in it, and I think we're well prepared in dealing with these types of issues. Although, as we move away from an industrial-based economy, we're looking much more at either light industrial or office-type environments or places where these types of issues can occur and do occur, but we have an absence of the uh, classic industrial hygiene types of hazards.
I can't get out of my head this analogy with occupational hygienists as general practitioners of the
Mm-hmm.
built environment, in that you have this multidisciplinary experience base, and you're kind of a first line of defense for health within the built environment. And I don't know if it's the correct analogy, but for some reason I keep coming back to it because I think it's quite a useful one to have in mind, that it is a multidisciplinary skill. And we often talk about on this podcast, because by the nature of this podcast, we have academics and industry people and policy people and so on. And we're always talking about the need for much more interdisciplinary approaches. And there is a general practitioner role within the built
Mm-hmm.
environment, which is an occupational hygienist, which is, I think, is really interesting. The fact that you've actually got a discipline that's being trained, as you said, I don't know if that's still the case, but certainly was being trained in both health and fluid dynamics and engineering. Like, crikey, like there's three of the big silos right there.
Yeah.
for managing outcomes in the built environment. So I thought that was really interesting. The note I made was knowledge economy. And the reason I made the note knowledge economy is that it's a fairly new term. But if occupational hygiene was growing commensurate with the knowledge economy, because that's not industrial hygiene, it's occupational hygiene, and there's so much value in that locked up and bound up within the performance of the knowledge economy, you'd imagine that an occupational hygienist would be very valuable in that sector, not just in managing poor outcomes, but in optimizing spaces for the best possible output. Because there's probably few roles that are better placed to understand and interpret the environment than an occupational hygienist in that knowledge economy industry. So I think that would probably suggest there's some headroom there for that sector to grow into.
It became quite clear to me early in my career that if you're just looking at this little sliver of the built environment or the work environment, air quality issues, that you're missing the larger picture of wellness that exists or doesn't exist there. So very early in my career, I became quite interested in ergonomics. And the hook that got me into that was looking at office environments where people were working with video display terminals. So we're talking, here, the early 90s. And VDTs were a really big issue, and they were a really big issue in terms of eye strain and in terms of musculoskeletal strain. So at some point, it became important to me to pursue that. I became certified as a professional ergonomist and really focused not just on the chemical exposures or the air quality exposures in an office environment, but also the physical exposures of noise, crowding, and then the musculoskeletal issues that came about as a result of the work demands. So that really seemed to me to be the comprehensive approach to that I was looking to have to truly understand all of the issues that were impacting on wellness. At the time, that was not a very popular way to think about things. And of course, there's not very many people who are certified as industrial hygienists in the US as well as ergonomists. They tend to be academics. But in terms of practice, it just made total sense to me that, how could you look at one factor that's impinging on someone's well-being and ignore all the others simply because it was a different discipline? And it turns out that if you worked at all of this from the metric of complaints of whether people were satisfied with their work environment, in their minds, they weren't, distinguishing between chemical stresses and ergonomic stressors, right? They were seeing any and all of these things as problems, and, whether the symptoms were eye irritation because of poor orientation of the work area, or a very glaring window behind their screen, or because of a chemical in the air, from their perspective, what's the difference, right? We may say,
Yeah.
oh, this one is ergonomics and the other is occupational hygiene, but in reality, for the individual, they certainly don't break things down in that way. So I do think that it became very clear to me, and I really feel like now there's a much greater awareness of these issues, and we have programs like Well and Lead and all of these other programs that have broadened their approach to look at all of these factors, and they're even broader than what I'm describing because Well, for example, includes the availability of fresh fruit and food,
Yeah, yeah,
as well
sure.
as crowding, noise, all these other factors, and air quality. So, I mean, that to me is a mega trend that I've certainly seen develop, uh, and that I've been quite interested in, and always seemed very intuitive, but didn't really exist in that way in practice.
As a general occupational hygienist, are there very defined boundary conditions to that role? Do you, for example, would you extend out into what we now understand as indoor environmental quality? So taking into scope noise and light and vibration and thermal comfort and air. Would that be within the traditional boundary conditions of a occupational hygienist? Or is it more is it more defined than that?
Well, I do think certainly things like noise have always been in the province of occupational hygiene, in the sense that these are stresses at work that have health consequences and are covered by regulatory agencies. So pretty much whatever country you're in, here we have WorkSafe. In America, we had OSHA, or a state program, whatever you have in Great Britain and Ireland. All of those regulatory agencies cover a number of different factors. So all of those things have always been within the province of occupational hygiene. The problem with the built environment is that there's no standards. So in the absence
Yeah.
of standards, hygienists get nervous. And the more uncertainty there is around a particular issue, the more people shy away from it. So what I found over the years was that occupational hygienists either embraced these issues and found them fascinating and challenging, or they thought, you know what, this is like way too hard. It's just much easier to go somewhere and know what the target is and know what I'm measuring and approach it from that perspective. So the uncertainty involved in doing anything in the built environment really is uncomfortable for a certain percentage of people. And if you can't live with the uncertainty, then it's a real problem. So when I get approached by someone who asks me to assist with a problem with a building, if people are getting sick, I used to say to them, I'll help you in whatever way I can, but you should also understand that I may not be able to help you. Maybe 60 or 80% of the time, or 85% of the time, whatever. I'll be able to identify a contributing cause or several contributing causes. And if you work on those, you may be able to address these concerns. But a certain percentage of time, I'm unable to come up with anything that appears to be the problem. So you have to live with the uncertainty that I may not be able to help you, simply because our knowledge base is limited, and I don't have the
Yeah.
knowledge to really solve this problem. Usually it's solving a problem, and sometimes there's a simple solution, but sometimes you just have to walk away and say, I've given it my best. I've tried everything I can think of. and
Yeah.
and we haven't been able to identify what the concern is. So living
You
with
can't
that
define. You can't
uncertainty,
define an outcome. Like I guess you get
yeah,
nervous if you're not tethered to a standard. It's very
right.
difficult to demonstrate that you're one side of that or the other. It's probably a terrible analogy, but I imagine it's a bit like a GP moving into alternative medicine. That all of a sudden it becomes a little bit wishy-washy, and you're not. It's very difficult to define an outcome for a client at that point. So you're really into kind of
Yeah.
best practice, or yeah, I can imagine
I
that
mean, we
very
have
much
that
so.
in medicine too. We have plenty of
Yeah,
people who have symptoms. They go to the doctor, and they're not able to figure out what's wrong with them, and they go to new specialists and this and that, and maybe they'll describe over a 2 or 3 year period they've tried all this and that. No one has been able to actually tell them what's wrong with them and why they have this chronic pain or whatever. It happens in other areas of healthcare and public health, right?
Yeah, for sure. So tell me a little bit about your kind of specialism then, because as you've described it to me, that you're an occupational hygienist, but also you specialised in some way in indoor air quality, which is relatively unusual for occupational hygienes. So, well, what is that specialism, and perhaps why would it be so unusual? Is it just because it's a new field, or it's it's only delivered out of certain institutions? What makes it so rare?
Well, people who work in indoor air quality in the built environment come from a variety of disciplines, depending upon what they're dealing with. So, if you're dealing with humidity and mold, someone may come to that environment with a background in microbiology, or they may come to that from a background in HVAC engineering. They may be professional engineers who design systems, and now they've kind of evolved into looking more at the indoor environment in a broader sense. So there's a lot of different disciplines that can come to it. Of course, if you've got these 5 or 6 or 7 disciplines that's necessary, then you need to learn about the ones that you are not expert in. So if you're building scientists coming at it and you want to learn about maybe the microbiology or the public health or whatever it might be, you kind of have to, train yourself to be able to understand those issues. It's true that most occupational hygienists end up taking a job and working in a particular industry. So here in Australia, we have a lot of natural resource extraction. So we have a large number of occupational hygienists who have spent their entire career in mining. And I think it's just like any other discipline. Once you develop a specialty and an interest in one area, you tend to stick with that and then rely on people who have expertise in different areas as well. But it's just an uncomfortable area for many hygienists because of the uncertainty that we talked about earlier. So it doesn't attract that many people.
Yeah, and it's. I was talking to Karine Mandin this week, who's an epidemiologist, and I thought what was fascinating about that discipline was the investigatory element to it. That you're dealing with so many confounding factors. How you structure that research and that science is absolutely fascinating because it's the making or breaking of a good or bad epidemiological study. And you have to have a really inquisitive mind, I think, to be an epidemiologist. You have to have a good imagination of what might inflect an outcome in that space. And you noted, I think, at the beginning there that there's a solid epidemiological element to occupational hygiene as well. And I imagine no more so than with indoor air quality, that we're dealing with risks that can have so many confounding factors. You're dealing with health outcomes where you've got workers that are exposed to chronic levels of things that might be affecting their health, that they could be exposed to in all sorts of different environments, with all sorts of different vulnerabilities, with all sorts of tolerabilities of risk. It must be a heady mix going into a space where there's a generalized complaints of sick building or unwellness or poor outcomes in some descriptions, and having to start to tease that apart. I imagine that's a really fascinating part of the job, actually, is that blank canvas greenfield project where it's hey, Brad, could you come in and have a look at this? And you then start going through your process, whatever it is, to start teasing apart what these, like you say, that the pathways are, the receptors, the generators of the risk, how you start to break that open and figure it out.
Yeah, I mean, epidemiologists associate exposures with disease. The training that I received in epidemiology and the focus that I had on epidemiology in graduate school. And, the thesis that I did associating wood dust exposures with laryngeal and other cancers, all of that to me is exactly the same process. You have multiple possible causes, you have confounders, you have a true relationship of linking the exposure and the disease, you have the quality of the exposure assessment, the quality of the diagnosis, the disease. All of those principles really are carrying across very, very much so. So, having one foot in that world of public health and epidemiology is a very good background and way to understand these issues.
So practically, how does that manifest typically uh, when you're in that world of occupational hygiene with a focus on air quality? When those calls come in from people to say, look, we think we've got a problem, we've got a series of complaints that we've not been able to uncover through our normal processes of calling the HVAC guy in, and Joe's got a mate who understands this stuff and he couldn't figure it out. We think we need some proper help here.
I think what you do is often not as important as how you do it. So because you're dealing with human beings and their perceptions, and because the connection between exposure and some type of health outcome is very fuzzy. So, for example, people may smell an odor, and that may manifest itself not as a true toxic response in a classic occupational hygiene way, but it may be that they smell this odor and somehow they end up with a headache, or they end up with malaise, or they end up with this or that. How that's actually happening is a very different toxicologic model than being exposed to 100 ppm of xylene or toluene or whatever. It may be mediated from, the fact that the receptors in the nose go through the trigeminal nerve and end up in a primitive area of the brain that we think of as the fight or flight response. And that type of an odor manifests itself then in a physical way. So you could be, in many cases, dealing with a very different phenomenon in terms of how people experience the health. In addition to which, there's always this human resources aspect to what you're doing, because when you can't see whatever is creating a problem, or you don't think there's a problem, then the people who are experiencing the symptoms must be crazy, or something is wrong with them, and there's nothing wrong with the environment.
Yeah,
troublemakers, they're this, they're that, and you generally don't see human responses that are across the board even, right? So one person may be severely affected, and maybe that person's atopic, or maybe that person has a particular susceptibility or whatever. And other people are saying, hey, there's nothing wrong here. What's your problem? Clearly there's nothing going on. So that makes it really challenging when you're assessing or investigating it, because you want to be able to validate the experience of the people who are having problems, not make them feel like pariahs, and make sure that they're participants in the assessment. So the worst thing that could happen is when you arrive on site and the employer says, listen, I want you to tell me what's wrong with the building. I don't want people to get upset. So can you do your assessment in the evening or on weekends when no one is going to see you? And you could do whatever monitoring you want, but we really don't want the employees to know you're here. And we're not going to share the report when it's done. And what I'll say to them in a situation like that is that generally does not bode well for a successful outcome, because the outcome is not just technically based. It's also based on people understanding that you're concerned about their well-being, that you're looking to intervene. If you've brought me in as a consultant, you're paying me a bunch of money to do this work. Obviously, you're concerned about it. So what I try and encourage the client to do in a situation like that is to introduce me to the workers, let me talk to them, understand their concerns. I might do that as part of a group process, but I might also say, hey, if you have some health concerns that you want to talk to me about, this is my telephone number. You can call me and we can discuss this privately. So if you don't feel like sharing, the fact that you're having this or that symptom, or you have a rash all over your rear end with everybody in the room, you can do that privately with me, and I'll keep that, confidential and protect your identity. So involving the people who are experiencing any type of a problem very early in the intervention, and getting them to buy into the process. So at that point, I haven't decided what I'm going to do or what testing I might do. And I might not be doing a lot of testing. But before I do that, I'm going to try and query the people involved and understand their concerns, and then develop a hypothesis and perhaps do some testing that tests that hypothesis. But by bringing them all along in the process from the very beginning through, if you don't have a successful outcome, at least they understand what's been done. And I could stand up in front of them and say, I'm unable to solve the problem, but this is what I've done. These is the issues that went through my mind. These are the hypotheses I formulated. This is what I tested. And even if you're unable to successfully kind of find the smoking gun, which is often not the case, but even if you can't do that, perhaps you could have a successful outcome to the assessment, and the problem will have been managed from a human resources perspective. So how you
Yeah.
do the assessment is often more important than what you actually do. So that really is a very different risk communication and risk management approach than when you're coming in and simply measuring something in a traditional occupational hygiene mode.
It's really interesting you mentioned risk communication there. Is that a big part of occupational hygiene? The
Yeah.
that often what you're
It,
trying to do is frame risk for people, because risk is very rarely eliminatable in a lot of general environments. So often, I guess what you're trying to do is provide people with the information to understand risk, and to manage risk. Um, is that a big part of the role?
Yeah, I mean it's very critical, and if you look at any occupational hygiene program in industry or even in an educational program at a university, teaching occupational hygiene, risk communication is a really key part, because the moment you
Mm.
go in and start measuring something on a worker, you're hanging a pump on someone to measure their silica exposure or measure their welding fumes or whatever. They're often going to say to you, "Hey, is this shit killing me? What do I need to know? How bad is it?" And then, of course, you have people who come home at the end of the day and they blow their nose, and it's all this black material because they're working in aerospace with composite materials that produce fine, dark colored dusts. And their wives are like, what's going on here? Everybody in the back of their mind knows about asbestos. They know about other things. We've had a lot of media attention on silica exposures for synthetic countertops in the last year or two. So people don't know what's really bad and what isn't really bad. Sometimes they're really worried about things that are not that hazardous, and they're not worried about things that are hazardous, because the clues they're working off of may simply be the visual appearance, or something like that, not necessarily a sophisticated analysis of the toxicology of what it is they're exposed to. So
Yeah.
yeah, you are always dealing with people's perceptions, and those perceptions can be accurate and reasonable, or they can be completely off the board. They could be reacting to something that isn't a concern or completely ignoring things that aren't. There's a really classic book by a man named Peter Sandman uh, that I found early in my career. He was actually commissioned by the American Industrial Hygiene Association to write a book on risk communication that I found to be extraordinarily helpful to understand how people perceive risk in the workplace and in occupational health and in air quality situations. Uh, that to me, that was a real eye opener in terms of appreciating the way that people perceive risk. And the central tenet of his book is risk equals hazard plus outrage. And hazard was all the technical stuff that the technical people focus on, but the part of the equation that was really most important was the outrage component. so that if someone was really outraged about an issue, then that could be way more powerful in their perception of risk than the true risk of the situation. It would be a very
Yeah,
long
interesting.
discussion to get into his entire thesis, but it's certainly something looking to look up. Peter Sandman.
Yeah, no, I've just noted it, and I'll pick that up with you separately, Brad, because risk communication is a real thing of mine at the moment. I'm trying to
Mhm.
understand personally much more about it, but I think the general air quality community could really do with understanding how we communicate risk much better, not just at the very poor outcome end of things, but also in this much more esoteric, long term, chronic challenge we have with communicating risk. How often are you walking into environments and within 10 minutes you know what the problem is before you even put pen to paper or start asking questions? Is it the
Yeah,
kind of work environment where your spidey senses are tingling as you walk through the front door, and you have a pretty good idea from the first two phone calls and your first breath of air that you breathe in a building what's going on here? Does it get a bit like that in the end? And
it,
you kind
it,
of you're walking through a process, but you know where this is heading.
sometimes it does, and sometimes it's surprising and almost humorous. I had a project in Cairns, which I know most of your audience is not here in Australia, but we're talking 4 hours, 3 to 4 hour flight from Melbourne to the northern portion of Australia, the tropical portion of Australia. And it
Yeah.
was a government office where people were complaining of either odors or illness or whatever. And I arrived, I greeted, I said, "Can you show me the mechanical room that serves this area?" And very often, with a mechanical room and a central system, the fan will be sitting in the center of the mechanical room. And as you look on the sides of that room near the ceiling, there's a whole bunch of openings from ducts that are the return ducts from the different portions of the building. Those ducts simply open up to the space. The fan is in the space, so it's sucking air from the room. The room is really part of the return air pathway into the fan, and then the supply air coming out of the fan is ducted, to each area. I walked into the room. I looked at on the left, and there was a P trap, which is the plumbing. I don't know how you would describe a P trap for the people in the audience who don't know what it is, but it's that squiggly thing that goes down and around and up underneath your sink that allows a cushion, a couple of inches of water to sit in the bottom of the trap and provide a seal such that the air in the sewer doesn't come up through the pipe that's draining the sink or toilet or whatever it might be. In this
Yeah.
case, it was a computer room air conditioner that was keeping the computer room cold. Moisture was condensing on the coils, and in theory, this was the pathway that moisture went into the sewer system. And of course, the minute I walked into the mechanical room, I saw that this was sitting in the mechanical room. I pointed to the trap and I said, "Have you checked the water level in that trap?" So, I mean, I wasn't there more than 5 minutes, and they were like, "Oh." And of course, the trap was dry, so that you now had this very nice pathway from the sewer system into the mechanical room. And the mechanical room, being the return air pathway for the building, was under a tremendous amount of negative pressure, all the negative pressure that the fan could muster to suck the air back from the space was also sucking the air out of the sewer system that the building emptied into. So that was the source of the complaints. And it just seemed humorous that I had flown, 4 or 5 hours, traveled 4 or 5 hours, flown 3+ hours to get there. And within 5 minutes, it was quite obvious what the problem was. We often
So,
see problems with sewer venting and buildings if somehow that seal is broken, or if there's an abandoned drain in a wall. A sink used to be somewhere, and they removed the sink, and they didn't properly cap the drain. Now you have a pathway into the wall cavity that's directly connected to the sewer system. So if you have the right pressure relationship, if it's negative pressurized in the space relative to what's going on in the sewer system, you're going to be sucking air into the building from the sewer
Nice.
system.
Yeah. And who knew that come full circle, Brad, to our conversation at the beginning before we hit record with, did you try turning it on and off again?
Yeah.
That it's the occupational hygienist's version of, have you checked the traps before I jump on a flight? I guess there's probably a few of those, is there, in occupational hygiene before you fly across country? Just before I jump on a plane, have you checked these 2 or 3 things that might just be worth it before I turn up? Might just save you a few bucks.
Maybe it's just worth mentioning that for doing assessments of large commercial buildings, that one of the first things that's useful to do is try and understand if the building is operating slightly positively pressurized to the exterior. The logic of that originally comes from the idea that you really don't want infiltration of air from the exterior that's unconditioned, that's perhaps carrying traffic-related pollutants or other pollutants. But it's remarkable how many problems occur when a building, for example, when the return or the relief fans and the toilet fans and all the other things that are sucking air out of the building, when that volume of air exceeds what's coming in the outdoor air intake, and then all the problems that occur as a result of that building running negatively pressurized, not to mention the fact that you have infiltration of outdoor air that's unconditioned and contains pollutants. But the other problems that can occur from that, I think that was, when we talked about commercial buildings, that's certainly something worth keeping in mind as a first cut, understanding what's happening with the ventilation system. I guess if you think of what are the first things that I would look at the building pressurization. I would look at any source contaminants that may be present indoors or outdoors that could enter the building as a result of that. I would look at the strategy for bringing in outdoor air and moving air around the space. Is the volume of air that's moving through the space reasonable? Are the returns operating properly? All of those are probably the first cut, quick and dirty things you look for to try and figure out if there's an easily solved problem or even a smoking gun. If you've got a building running negative and you've got contaminants, I'm thinking of one where they would spread what was called in America beauty bark that's been chipped off of trees that are going through the sawmill. And if you let that sit wet for an extended period of time, you get all kinds of bacterial and fungal growth on the organic material. And in this building, they had simply spread that in the flower beds that were surrounding the perimeter of the building. So whenever they turned the system off at night, the building, through its natural stack effect, was sucking the odors associated with all that decomposition into the building, so that when they turned on the system in the morning, people came in and it smelled horrible. That was an easy one to figure out. But again, the building should never have been, negatively pressurized. And if that was happening during the occupied period, it would have been a continuous problem that wasn't just isolated to the morning. It would have been something that would have been present all the time. So whether it be beauty bark that's biologically decomposing and is giving off a lot of odors, or whether it be soil outside the building that a leaking underground storage tank has saturated with petrol, gasoline, depending on what country you're in. All of those are problems that wouldn't exist if the building wasn't negatively pressurized. So, in the spirit of getting that low hanging fruit, that would be one of the first ones I would think of. And since we had talked about that, and I had just recently given that talk on pressurization and the problems that could come, I thought I would at least mention that.
Yeah, no, I think it's a good point. And it's one of the, as a ventilation person, principally, it's often one of the first questions I'm asking about buildings is, okay, what's this building actually doing? But I've typically found that a very difficult question to answer, because we've never really set buildings up or HVAC systems up to determine that post fact. There isn't a lot of skill set out there to determine that as well. You'll
No.
get maintenance people that come round and clean coils and check refrigerant levels and things like that. But a good example of that is in Ireland, we've just introduced a code of practice to the workplace. And one of the fundamental things they're asking in that code of practice is every year or two, at least, you're doing a ventilation performance check on the building, that you're checking that you're getting 10 litres a second per person in the boardroom, and that the open plan office space, the zones are getting what they should do, and all of these kind of things. And that's very easy to write on a piece of paper, but practically, I don't know if you found the same thing, almost impossible in some circumstances going into buildings to come away easily with a good understanding of ventilation performance in a
Yeah, I mean, one of
non-residential
the
space.
things it's you bring it up, and it's an important one. And one of the things that's, I think, special and meaningful about OSHRA 241, control of infectious aerosols, is that you're basically, in order to be in compliance with 241, you actually have to verify that the building is operated as it was designed. And that seems almost revolutionary. It's like, wow, you're actually going to try and figure out if it's working the way it's supposed to. And over
Yeah.
time, you've got a lot of mechanical linkages, you've got dampers. These are things that age and fail and perform differently, and you change the utilization of the space, you modify, you add, you subtract from the system. And a ventilation system, it's not like a electrical conduit where you could just add more plugs onto the system. The moment you add a new supply vent, or you add a new return vent, or you take away something like that, the balance in the system changes completely. You've now affected every other outlet in that system. Whereas in an electrical system, you put in a new outlet, it doesn't really change anything, right? So that concept of actually verifying that the system is working is remarkably powerful. And if we just did that on all buildings, residential and commercial, it would be wildly successful effort at identifying lots of problems.
I think the risk there, though, and speaking to some friends in France that have looked at this in detail, is that the conclusion that they've largely reached is that for the existing stock, forget about it. The cost and complexity of assessing performance in the existing stock, it almost outweighs the benefits that you'll get. They've just never been designed or set up to do that. And actually, you're probably better looking down the barrel of environmental monitoring to assess the performance, the outcomes in the space, to understand if it's working, rather than the aerolic performance of the ventilation system, because it's just going to be too expensive to do. They were just never set up to be somebody to go up a ladder and a handy nipple being where you want it to check the pressure or a flow rate of something somewhere. Most buildings just aren't that. And it's one of these concepts we often talk about in the podcast when we talk about the non-residential space, particularly in the context of well and reset and some of these kind of well-being frameworks. Our minds automatically go to a Deloitte's headquarters in Sydney, or an Arab's building in London or something. Whereas that's not reflective of most of the built environment. Most of the built environment is a basic offices above a warehouse in an industrial estate somewhere out in the outskirts of Sydney, or a solicitor's office above a high street shop, or a hairdresser's, or something else. And most of our built environment, most of our non-residential built environment, is a very, very long way from having building management systems and measurable HVAC systems and things like that. And they've just been designed to run to failure.
I think I would argue the reverse. I think I would suggest that it's not that complicated to go through a building. So I'll give you an example. As a result of concern for infection control management, I went through a relatively new 2 or 3 year old building in one of our capital cities here in Australia. And in the course of a day or two, and this would be like 12 or 14 floors of a Class A office building, my technician went through measuring the flow coming from all of the diffusers, and was able to work from the commissioning data. So that was already in the spreadsheet. And it was relatively easy in one day to measure all of the operating characteristics of the existing system. And a number of deficiencies were identified in what was this really well built, commissioned, building. It wasn't that difficult to do that. And it was very productive in terms of identifying deficiencies, because if you were to say, what is the performance metric that you would do? It's not measuring carbon dioxide and inferring the ventilation from that, because the problem with that approach is that, yeah, if you see 1,500 or 2,500 CO2, that's a true positive in terms of it being a problem, right? Clearly there's something going on if the levels are that high relative to the balance of occupancy and removal ventilation. But the problem is with all the false negatives. The problem is that if you see 600 parts per million or 500 parts per million, you don't know if there's people in the space not generating CO2, or you don't know if the 12 hours it takes for CO2 to build up to its maximum concentration at zero point 0.2 air changes per hour, that it's been occupied consistently for that period of time. So you may pick off these egregiously poorly ventilated spaces with those true positive readings, but you're going to miss a huge number of things. The only performance test that makes sense for ventilation is something like a tracer study, where you're measuring the actual ventilation, using a tracer like SF6 or some other tracer, or if you're able to evacuate all the residents or occupants simultaneously at one point, like at 5 p.m. in an office building, maybe you could look at the decay curve of carbon dioxide. But generally, looking at some of these things, it's remarkable how valuable that type of an approach could be, and also that it's not necessarily an enormously expensive effort. So in this building, going through in one day with a flow hood and checking, a high percentage of the flow rates and looking and comparing those values with the commissioning values turned out to be quite productive.
Yeah. I suppose if you've got the commissioning values to work from, and you've got the systems that are measurable relatively easily, in a lot of spaces, particularly with split systems where access to the supply might be quite difficult, you might not have good canopies and things to put stuff over to measure easily. All of a sudden it can become quite awkward to measure spaces. I guess it would depend from building to building, but it's one of those things that's very easy to write on a standard, is that thou shall check the performance of the ventilation. It seems objectively obvious that that's what should have been happening all along. But in practicality, we know that's never happened. You're lucky if you can find a commissioning document. The system's probably been butchered and fiddled with over a decade or so, and you've got hybrid this and a change in that and an alteration here or there, and partitions have gone up, and the ventilation system's now split between one space and another, and it becomes a hot mess quite quickly. And so a simple paragraph in a code of practice that says, or 241, that you need a document that shows that you're meeting the performance requirements of the building, you start scratching the surface of that often for a lot of buildings, and people get sweaty pretty quickly because you realize that's not. I've done a lot of assessments, initial assessments, and nearly always the first step is the bit that people have got stuck on, and that is, we need to understand the performance of this building. That body of work often is quite a body of work to be done.
Sometimes there's very obvious deficiencies. I could think of 2 buildings that I assessed in the same way you're describing. In one of them, I went in and started playing with the building management system. And, it turns out that the outdoor air intake, there was a toggle switch that was turned off. And when I asked them about it and why it was turned off, they had no idea. They just didn't understand the system, had lost the institutional knowledge of how to operate it. And something as simple as a single toggle on the BMS was able to change the entire operation of the system. or another one that I can think of, a school where it had two different differentially sized compressors for the air conditioning system. It was it was an expensive Italian system that was designed, with maybe a 30% and a 70% compressor on the AC system. And it was designed that when the load was relatively low, the electrical contacts would be closed on the 30% system and you'd get the cool air coming through. If the load raised and it was moderate as perhaps the temperature increased outdoors, you would turn off the 30% capacity one, turn on the 70% capacity one, run that. And then on your degree days where you really have a massive amount of cooling, both would be energized. And they simply, when they commissioned the building or when they built the building, they simply had them toggled in to run together. So basically, no matter what the load was in the building, both compressors turned on. You had 100% of its cooling capacity, cooling the air down to this ridiculously low temperature, which was then discharging from the supply diffusers, freezing the occupants for a short period of time. And then the system would turn off. And you had this seesaw effect where the temperature would then rise to the point where it was uncomfortable. And then you'd have this massive amount of cold air blowing out. So it was a reasonably simple problem that had a very simple solution to simply rewire it the way it was originally intended to operate in the specifications mentioned. But just going through that, in the same way that going through that other system and realizing that toggle was off was wildly productive for very minimal effort. So, another low-hanging fruit in that regard, in addition to those measurements, is simply to look at how the BMS is set up,
Well, just that simple shift in mindset from giving a damn from run to failure, is probably the biggest leap most organizations can make when it comes to managing ventilation infrastructure. Is we'll fix it when it starts making a knocking noise, to maybe we should care that this thing is running the way it's intended. That could be the big, and just asking that question, it can open up all sorts of opportunities.
Yeah, I think so, because the accountability we have in the system right now is basically hot calls, cold calls, and the cost of energy. So if you were to say, what are building managers or facility managers being held to? If no one is complaining about being too hot or too cold and the costs are moderate, then everything is great, right? And of course, when we had the pandemic, suddenly all those people were being told, well, operate the system to minimize infection risk. And it's like, well, wait a minute, that was never part of our metrics here. It wasn't part of our KPI, infection risk. We just had to keep people from hot calls, cold calls, and make sure the energy bill was moderate. Suddenly you're asking us to do all this other stuff. But yeah, we need to do that. We need to ask them to be accountable, not just to making sure the thermal conditions are acceptable, but looking at other factors too, including how the system is operating, whether it's bringing in appropriate ventilation air and the like.
While I have you, I just want to briefly talk to you about Ultra Protect, a partner of this podcast. Look, they're not here by accident. Like the podcast, they are passionate about driving changes in our indoor environment and are an all-round great company to deal with. Ultra Protect provides cutting-edge technologies and services focused on air quality and dust management. They have years of experience in the industry and a team of people I have leaned on many an occasion for advice and insight. From continuously tracking air quality to specific sampling, they analyse and provide actionable insights in the built environment. Specialising in dust management, they provide amazing products and services that minimise risk and improve environments from construction sites to offices to manufacturing settings, through to solutions around ventilation aimed at improving the environment in the long term. It's a company well worth checking out. There are links in the show notes on airqualitymatters.net and of course at Ultra Protect UK. Now, back to the podcast. I lost complete track of the question I was going to ask then, which was, oh my goodness, what was it now? This is the trouble, you see. I think of something, I say, well, I must go down that, ask you a question about that, and then, but I've made a note of something I wanted to jump back on before I do it, and then I completely forgot what I was going to ask you.
When you and I met over in Copenhagen at the AIVC, I think I was particularly impressed by Benjamin Jones' paper on DALYs, disability adjusted life years, as a metric for understanding the impact of indoor air quality contaminants. I'm really excited about that because I think that that's where we're going to be going long term. So if we think of outdoor air now as a dilution for the contaminants in the indoor environment, which is kind of how we think of outdoor air, that we bring it in to dilute away all the internally generated contaminants by people and activities and building materials. I think sometime in the future, hopefully not terribly distant future, we'll try and create indoor environments where the air quality is better than outdoors. And ASHRAE 241 is one step in that direction, in the sense that we have an equivalent air for infection control, as opposed to ventilation for some other purpose. And generally, the most economical way to achieve that is to provide additional internal filtration of the air. But I think sometime in the future, we'll be able to filter the air indoors for all the contaminants that might be present and begin to create indoor environments that are cleaner than the out of doors. And that will take care of the episodic problems we have with things like bushfires or forest fires, wildfires, whatever country you're in. Here, they're bushfires. In the U.S., they're wildfires. But when very high particulate loads are present outdoors as a result of traffic or burning of forests or whatever it might be, that we could look towards a period when we'll have much, much better air quality indoors that could manage even things like thunderstorm asthma. We had an episode that resulted in 9 fatalities about 5 years ago here in Melbourne, when the pollen in the air got sucked up into the upper atmosphere, became hydrated, the large pollen grains cracked into many, many small particles. The air currents carried them down, and people who might have had upper respiratory issues with large pollen grains suddenly found their lower lungs exposed to the same allergens. And instead of sneezing, they had an asthmatic reaction. Their airways tightened, and we had hundreds of people being taken to the hospital and 9 fatalities. So there are even these unexpected events that occur outdoors that we would love to be able to protect people against. I just think that the approach of trying to consider thresholds for indoor air that are health-based is a really exciting approach. And Benjamin Jones and Max Sherman and Morantes is another author of some of those recent articles. What they're suggesting is that we prioritize our indoor air pollutants on the basis of their health impact. So looking at the concentration of typical levels that we have for specific pollutants, and then looking at the toxicology, the human toxicology, the animal toxicology, to rate these in terms of their degrees of morbidity and mortality. And the DALY, the daily approach, is to say, okay, not just, is this causing chronic mortality, but is it causing morbidity as well? And can we put that into the metric? When you do that, it turns out that the 4 or 5 pollutants indoors that explain 95% of the variability in health outcome are, PM 2.5, PM 10, formaldehyde, ozone, and radon. So when you take that health-based approach, then you really have a laundry list of the things you ought to be working to control if you want to have the greatest impact on health. So I think that's an exciting development that's been coming along for the last decade, but particularly in the last year, I feel like there's been a lot of traction to look at that. And I think it's very possible that ASHRAE will be looking at something like that in some of the future standards, 62 outdoor air ventilation, looking also at how do we control for health rather than using dilution, but by managing the concentration of these high priority indoor pollutants.
Yeah, I think it's a really interesting idea that, and for listeners, if you haven't already heard them, the very first episode with Max Sherman that I did, and also the episode with Ben Jones, really dives into that idea of DALIs and total harm of some of these pollutants. I think it's an interesting concept. A question I have for you on it is that obviously the work that they've done to date has been focused on residential settings. So we have a series of pollutants, 4 or 5 of them that represent the vast majority of the harm in the space. It will be interesting, and I know there is some work ongoing, how that translates to the non-residential settings. In your experience, that those kind of top fives, particulates, combustion products, and off-gassing from materials, which is the top 3 really, PM, nitrogen dioxide, and formaldehydes, and their equivalent pollutants that come along with them, would they be representative of what you see in the non-residential setting as often main pollutants of concern?
I think there may be a difference in that when you talk residential, you're talking about a lot of sources that usually aren't present in office environments or public
Yeah,
buildings. You've got cleaning products in both, but probably you have much more intense use in the home. And you've got cooking in the home, which is a
yeah,
huge source of pollutants, whether it be oxides of nitrogen from a gas stove or particulates that are produced by cooking and not really removed by the ventilation, the kitchen ventilation. Plus, it's worth remembering that if we spend 90% of our time indoors, 70% of that is spent at home and 20% might be spent in other buildings. So your bang for your buck is greatest if you attack the residential from a public health perspective. You're going to have more bang for your buck there. But we still have things like traffic related air pollution in both. I saw a study recently that looked at traffic related air pollution in Melbourne, that was looking at daycare centers and primary schools and their proximity to heavy truck traffic that resulted from the rerouting of a freeway type thing. So, you do have issues in schools of that type of pollution. But I think, in terms of public health, the focus is appropriately focused on where we spend the majority of our time at home. And then we also have programs like Well and LEAD and Green Star and all of those programs that are trying to address air quality in offices. And most public buildings have reasonably good outdoor air intake capability. Whether it's happening or not is another story. And they have reasonably good filtration. So even though they may not have extremely high level of filtration, they have filtration that doesn't exist in residential homes. Generally, you may not have any outdoor intake in a residential system. And if you have a filter in the air, the filter is basically there to prevent large chunks and boulders from interfering with the fan. It's not really
yeah.
designed to pull particulate out of the air, and doesn't pull particulate out of the air anywhere near the efficiency that a commercial system would do. Commercial systems have to protect the coils, and there's big energy penalties for having dirt on your coils and reducing the efficiency of heat transfer. So there's big bucks involved in preventing inefficiencies in an air side system in a commercial building. And of course, that's not really considered or thought about much in a residential setting. So I think we do a pretty good job in commercial buildings versus residential in that area. Not that there isn't room for improvement, but I think that the focus is appropriately on residential buildings for those issues.
Yeah, and as you say, if nothing else, for the amount of time we spend in those buildings, if you're going to get your bang for your buck, that's where you start. And
Yeah.
I don't know if you agree, but one of the other interesting things about that work is that the pollutants of interest that float to the top we understand very well. We understand how to manage them very well through very basic first principles of hierarchies of control. We we've got the tools available to us today to have very large impacts on those main pollutants of concern. And I think that's what's encouraging about that work, that we're not looking down the barrel of 60 pollutants, all with relatively similar harm, that all interact with each other in enormously complex ways. And it's going to be very difficult for us to untangle a way forward. We're basically talking about filtration, removing combustion appliances, and local exhaust ventilation and source control. I mean, real first principles stuff can have some really big impacts in those spaces.
Yeah, and in general, we do a really poor job. I mean, here I was really stunned because I spent so many years in the U.S. I spent 6 years in New Zealand, and now it's been 10 years in Australia. But it's extremely common in both New Zealand and Australia to have your dryer vent to the laundry room and not to the exterior. I don't think I ever really saw that in America. Everybody had the little kits with the hose leading to the little galvanized exhaust that you had in the side of the room, and all of that moist air was exhausted to the exterior in the U.S. Here, it's rare to see that. I mean, we have condensation based dryers in the last 10 years that I guess have become more popular, but it's completely considered normal to not have your dryer be vented. And the number of kitchen vents that are not operational, the number of bathroom vents that are not operational is remarkable, and the buildings where these things don't even exist. Uh, I know at some point in the last couple of years, I was stunned to find that in the passive house community, they were using cooking vent uh, systems that were just filtration and not
Yeah.
connected to the exterior. And that was because it's a problem when you have an opening to the exterior and you're trying to create a tight building. Not that it can't be managed; it's a little bit extra effort and work. But to think that you would actually be recirculating the air from cooking back into the building in an advanced passive house was I was stunned.
Yeah, for sure.
And I don't know exactly what's happening with that now and whether or not that's being done differently in the UK
Nothing.
versus.
No, it's been ignored largely. In low energy buildings is the requirement for significant exhausting of cooking pollutants. I was talking to Ian Walker there last week on the podcast because, as you know, he's done a lot of work on cooker hoods and particulate matter and capture efficiencies and so on. And the kind of thresholds for volumes of airflow that he was talking about for cooker hoods to start to be practicable um, made my eyes water. And from my experience of measuring flow rates in cooker hoods, we're not even close. I mean, we are a million miles from where we need to be for cooker hoods, never mind passive house recirculating problems. Even when we
Yeah,
have a cooker hood, you're lucky to see it doing more than 10 litres a second, 12 litres, because
yeah,
they're the cheapest, worst possible pieces of crap that you can buy to put in the kitchen because they have no value to anybody. So nobody's spending any money on them. Yet they're likely to be the most critical piece of infrastructure we have in the home from a pollutants perspective.
yeah,
And 60 litres a second, 80 litres a second that he's talking about, good luck. I mean,
yeah,
I don't know how many times you've seen a cooker hood actually achieving 60 litres a second,
yeah,
but I can count on one hand probably in my career. So like there's a
yeah.
really long way to go with that one. That's for sure.
Yeah. I mean, and the design of a canopy hood, when you're talking exhausting industrial dusts and vapors and things like that, a canopy hood is not a really efficient way to do it because you're losing a lot of what's being generated simply because you can't have enough suck on that hood to overcome the losses because of all of the large opening that you have. So it's not
Yeah.
really a very effective type of a hood. So even if it has that flow that you'd like to see, you're only capturing a percentage of what's being generated. And moisture is a huge issue. whether it's generated from cooking or from bathrooms or from a rice cooker in the kitchen that's not under a hood, huge issues with moisture and mold. So, managing moisture indoors is a really big issue. We have a problem here in Australia because in some of the warmer areas, we sometimes have conditions that extend over 3, 4, 5 weeks where it's not that hot, but it's extremely humid. And most residential systems are not condensing the moisture out of the air because it's not that hot. And they're inverter type systems that are working at 20% of capacity to save energy. And they don't actually drop the air below its dew point. So you end up with extremely high relative humidities indoors. We had an epidemic in Australia about a year and a half, 2 years ago, when New South Wales and Queensland had those kind of cool, damp days for an extended period. And suddenly people's homes, things were starting to get moldy and it became a big issue. And the moral of that story is that, you can't just manage on temperature in climates like that. You have to have dehumidification in residential environments if you're going to manage and prevent mold from growing. It's just the ambient humidity stays too high. The existing systems are not dehumidifying. It's not hot enough for them to operate on a heavy duty cycle and actually drop the moisture out of the air as it passes through the coil, or they're optimized to minimize their energy usage and re-evaporate the moisture on the coil back into the air, simply because the manufacturer has realized that they're going to get a higher energy efficiency rating if they wring every last bit of cool out of that coil. So the fact that it's re-evaporating the condensed moisture from the coil in the air is not a consideration. The coil turns off, the fan continues to run, and the fan will run until the coil reaches maybe ambient room temperature before it turns off. So, all of these issues play into the issue of moisture in a building and all of the problems that can occur when that's not managed properly.
Yeah, and it was one of the, kind of going back to Ben's work, it was one of the things that was the most common response actually from that work was where was damp and mold in that equation. And it's actually number 6 on the list, I think, comes under bioaerosols, but also a little bit under particulate matter as well. It's kind of hidden in there is probably the best way to describe it. But moisture control in buildings, without doubt, is both fascinating because it's very regional or country-based or geographical based, but also it's one of the few pollutants that actually damages the building as well.
Well, the one commonality, though, that cuts across all of that is the impact on the prevalence and exacerbation of asthma. Here in Australia, we have a very, very high rate of asthma. When I was in New Zealand, I worked at the Massey University, and I did an epidemiologic analysis, looking at the population attributable risk of moisture to asthma. And it worked out to something like 20%. Based upon the prevalence of indoor dampness and the impact, and the economic impact of that was tremendous. It's not that different across other countries. So even considering all those differences in climate, you have this pretty significant impact on the population attributable risk of asthma simply from indoor dampness. So there's a huge economic incentive to address that issue. Not to mention the fact that you've got all those miserable people having a hard time as a result of the indoor moisture.
Have you found yourself looking increasingly into the residential sector? Is that something that you've found yourself doing? Because I can't imagine that's a natural place for occupational hygiene, is residential settings. But clearly it's an area that you've found yourself looking at in some way or other.
To a certain extent, yes. And if I can speak for the profession as a whole, there's some specific issues that have hooked hygienists into residential buildings, particularly single residential buildings. And those are really asbestos, not so
Yeah.
much here in Australia, but in America, lead and lead paint. So
Uh-huh.
managing asbestos, managing lead, mold, um, those are the
Okay.
hooks that have brought hygienists into the residential environment. And if you're talking about consultants, it's really a question of what the demand is. There's definitely
Mm.
demand for people to address exposures to asbestos in buildings. Here in Australia, we have, I think, among the highest methamphetamine use in the world based upon the levels of amphetamine they find in sewage. So we seem to be the world leader in methamphetamine usage.
Nice.
And we have issues with buildings where people either have synthesized methamphetamine, so clandestine laboratories, and we also have issues with where people have smoked methamphetamine, where the vapors condense on the walls, and then you have the possibility of a third hand exposure to the new residents of a building. Uh, Obviously, if you've got children present while you're cooking the meth, they're all going to be exposed to the solvents and precursors you're using. But the process of cooking actually condenses the methamphetamine on the walls, and then it stays there. It could stay there for years. And it's going through this process of either skin absorption or evaporation into the air. For an SVOC, that's relatively low, but you are getting some evaporation and recondensation over time, and that possibility of exposure to third-hand methamphetamine. So that's brought hygienists into the residential environment. Asbestos, lead, meth, those kinds of, and mold are the ones that have, I think, because we have the expertise that we have, we're kind of the logical people to address
Yeah.
those concerns, right? So that's where I've seen people get involved. Obviously, consultants, particularly, have gotten involved in that way.
Yeah, I can't say I've had much exposure to meth labs, Brad. So that's fortunate. I guess that's a thing for you. Is if you found, because I noticed you have a paper or at least some articles
Yeah.
on meth remediation. That's a thing. I'm guessing.
Yeah, it's a thing. Partly it became a
Yeah,
thing in Australia because there were a lot of unscrupulous people running around uh, suggesting that the levels were extremely high and frightening homeowners, and houses being torn down because of the meth contamination. I recently did a project that was mediated through a lawyer, but it was a home where a consultant had come in and they literally recommended tearing the house down because of the levels that they measured of methamphetamine. And when I repeated the testing, I was unable to document levels anywhere near what theirs were. And many of the things that they were suggesting were associated with a grow house, cannabis growing, were like normal uh, irrigation systems that people might use for their plants and things like that. So they had kind
yeah,
of blown this thing way out of proportion, and were literally recommending tearing the house down. So we've had some unusual and unscrupulous assessors here in Australia that were kind of misleading people and frightening them. So yeah, it's been an issue here, and it's been an issue in New Zealand.
what is typical remediation for meth houses? Is it, do you have to deal with the surfaces in some way? Is there things that can counteract or neutralize the
Yeah,
chemicals that
there's
are there,
really
or do
two
you have to
options.
remove materials?
Now, if the levels are moderate, if it's literally been a clandestine laboratory and the level is egregiously high, then removing, say, the wall linings, the plasterboard might be appropriate. But
Yeah,
generally, you could either clean the plasterboard with several washes with, a strong surfactant, or you could spray it with an oxidizing substance like a foam containing hydrogen peroxide that will attack the molecule and break it up. Nobody really asked the question, what is it breaking it up to? Do we have any concerns? But when you test for meth after you've used an
it's gone.
oxidizing
Yeah.
foam, it's gone, right? So you end up with something that's an acceptable concentration, because we have guidelines here in Australia, government guidelines. They're not mandatory, but because we have a system where the environmental health officer in a particular council can red tag a home as being not suited for occupancy, it becomes a government mandate. So if the police bust someone for methamphetamine use and they go to their house with a search warrant and they find glassware and other materials that suggest they might have at one time cooked or were cooking in the home, they'll notify the health department. The environmental health officer will basically take away the occupancy permit for that building, for that residence. And until they're presented with a report from an occupational hygienist or another qualified person, then they legally can't occupy that residence. So that's a pretty compelling government intervention. I guess that doesn't happen in Ireland or the UK in the same way, but
not at the same scale. I don't think. We're quite lucky. I mean, there is methamphetamine in the marketplace, but I can't say I know enough to know about it, which probably suggests it's not that prolific.
So when you deal with methamphetamine, you're dealing with all of the chemicals involved in the synthesis and the waste products, many of which are solvents, toluene or acids or bases. So, we have that understanding and background of the toxicology and handling chemicals, disposal of chemicals. Sometimes they're disposed down the drain, so you need to deal with sampling the septic system. And then, we're exposure experts, right? So if you've got a semi-volatile organic compound that's coating the interior plasterboard, then we understand that, yes, that's evaporating in the air. It may be evaporating at a low rate, but there's a potential for exposure via inhalation. There's a potential for exposure via direct skin contact. A child rolling around on the carpet might have exposure to the overall body and skin. So, we're kind of well trained for that type of assessment. Surface sampling to see what the levels are per 100 square centimeters. All of that really fits into our province. So we are kind of the natural, discipline to look at those problems and try and understand the exposure assessment issues and do the measurements in an appropriate manner and submit them to the lab. And it's the same lab that we might be using for our occupational health samples are also geared up to do asbestos, to do lead, to do methamphetamine. So it's the same community of people,
Coming back to, have you got a little dog trying to get in or out at your place there? Or is...
I'm not sure what she's complaining about. The door's closed. There's not much I can do beyond that.
No, fair enough. Coming back to Ben Jones's and Max Sherman's kind of work, where we're looking at these kind of harm intensities, how do you envisage that progressing? That kind of idea, on the basis of you can't manage what you don't measure. If we're proposing thresholds or an interest in pollutants of concern, in some way we're going to have to understand our exposure to those. I think it's fair to say we're pretty close when it comes to particulate matter with things like low cost sensors. They're getting fairly reliable to give us, at least get us in the ballpark of what we want to understand about our exposure to it. But we're certainly, I don't think we're quite there with things like the NOxes and the formaldehydes, the chemical sensors and the metal oxide sensors are getting there, but they're not there yet, I would say. So it'd be interesting to see how that segues over the next few years, is to say, well, okay, if we're going to set standards for exposure to PMs and off-gassing of building products and exposure to combustion products, how we categorize and measure that will be interesting, and where that might intersect with something like the skill set of occupational hygiene,
Yeah. I mean, you're absolutely correct. Things like formaldehyde or limonene which opens up the whole door to reactive chemistry,
Yeah.
ozone and limonene being one particularly important compound in creating those reactive products that's often found in residential environments because it's so ubiquitous in cleaning products. All of those are a bit challenging to measure at present. I'm not sure how we're gonna deal with that going forward, but I think the velocity at which we're developing sensing technology, low cost sensing technology, has really accelerated in recent years. When I first started practicing, the CO2 measurement device that I used, was the size of a toaster, and it required a lot of calibration, and it had a finite battery life. It actually had an IR generator in it that was a tungsten filament. So if it wasn't plugged in, it didn't have a lot of battery life to it because it was heating up this tungsten filament, kind of like an old tube television, where it glows red. So all of that technology has been getting better and better. I think if there's a demand for it, hopefully we'll be coming up with the sensor technology that's going to be able to identify those.
Yeah, and as I always say, the understanding what you're exposed to is one thing, and certainly from a benchmarking perspective, it's important, to understand, like you say with occupational hygiene, whether you're in the red zone or the green zone ultimately within a space. But ultimately, you've got to do something with that information. And there are only so many levers we can pull, particularly in a residential setting.
Yeah, I mean, I think what we'll see in the commercial environment is the use of the sensing technology to validate the cleaning of the air. But in a residential environment, it will be, the performance of the hood in the kitchen, the performance of the bathroom ventilation, the connecting of use of the shower, perhaps with a humidity sensor that automatically turns on the fan. So the technology may be different. It may not be sensing technology. It may be more usage technology and performance technology. It's really easy to design a system that measures the velocity of air going through the duct leading from either the bathroom or the kitchen exhaust. That's a pretty low cost available technology, whereas it's pretty difficult to reliably sense and keep in calibration an oxide of nitrogen sensor in the kitchen, that may be looking to see what your exposure is. So probably, we may see that quote unquote low cost technology applied in the commercial environment. But in the residential environment, there's so much opportunity to simply work on the performance of the systems that, we may not even need to look towards sensing it. We just need to look towards validating the functionality of the path interrupters, in essence, or changing,
Yeah.
as you mentioned, the source controls by substituting different materials for cleaning and the like. We're not going to be able to substitute things for cooking. We're still going to be aerosolizing oil and things like that as
Yeah.
we cook.
And bioaerosols will still be around and things like this. So there's some things you can't eliminate or substitute. That's just the way it is.
Yeah.
But
Yeah.
that's the way it goes. Yeah, it'll be interesting to see how that progresses. I've been like you. I've been very excited by that work. I think it's an approach that's both refreshing and answers a lot of the questions that we've struggled to in this environment over the years of drawing that straight line between building performance and health outcomes and potentially unlocking resources that we've not been able to access before. The built environment has tended to be locked into energy resources predominantly. And if we can unlock health budgets and public health budgets and other things, it helps this sector enormously. So it will be interesting to see where that goes.
It's also, I think, really useful to remember, and the work of Kirk Smith. I don't even know if you've ever heard of him. He passed away probably 20 years ago, but he was one of the earliest advocates for addressing particulate exposure, not so much in developed economies, but particularly in the undeveloped world, where people are often cooking in the house, sometimes cooking with dung or uh, briquettes or some other organic source with no ventilation indoors. And, he did a great job of characterizing the enormous morbidity and mortality associated with those types of PM exposures. So, we've really, when we talk about this stuff, we've really focused on the advanced economies, Australia, Europe, the US. But it's important, I think, to keep in mind that from a global perspective, my God, there's so much that can be done to reduce disease associated with particulate material in these less developed economies. Just simply providing a ventilated cooking appliance, can have an enormous impact on exposure. So there's a lot of opportunity to improve global public health by
Yeah, I
focusing on
agree.
that.
Yeah. Well, I think it's important that both tracks exist, because often the track in this part of the world, uh, roadmaps, next steps for other parts of the world. When you get here, these are the things that you then need to start looking at. Had a fascinating conversation with a lady called Priyanka Kulshrestha, who works in Delhi. She's an indoor air quality scientist there. And one of the big impacts they had in cooking, exposure to cooking pollutants there, as you say, cooking with dung and solid fuels, you're talking about exposure to PMs in the thousands of
Right.
micrograms per meter cubed, like
Right.
just another level.
Yeah.
And one of the
Yeah.
biggest things they did there was provide decent funding for uh, gas bottled cooking, but also unintended consequences. So, what they've seen in the indoor air quality monitoring is enormously high peaks of PM, but outside of that, that drops down quite low because they're virtually outdoor environments, a lot of these spaces. But as you lift people out of poverty and they start to close those spaces in and start to condition them,
Yeah.
you then introduce chronic exposure to PM that wasn't there before. So they're now dealing with, in the the people outside of abject fuel poverty, um, exposure to 300, 400 micrograms permanently within the spaces, because the habits and culture haven't changed, but those spaces are now locked down and
Yeah.
conditioned and
They're
so
no
on.
more. Yeah.
So you get a new problem.
Well, the parallel here in Australia is that because the climate is relatively mild in really the majority of the country, you have to go to Tasmania or up in elevation to really get a climate that's similar to yours, for example. I was born
Yeah.
in New York City, and it just gets way colder in New England and the northeastern part of the U.S. So you just can't tolerate leaky homes. I mean, if you have
No.
a leaky home at minus 10 centigrade, the discomfort associated with those jets of cold air coming in is completely intolerable. So people very quickly realize they need to build tight homes. In Australia and New Zealand, that's a foreign concept. I mean, it never gets cold enough. Here in Melbourne, it really never even gets to 0 centigrade. So, we have a mild enough climate that you could tolerate a leaky home, and the same thing in New Zealand. I was stunned when I got to New Zealand. We immigrated to New Zealand from the US. We were looking at a house to buy, and I asked the real estate agent what kind of heat they had, and she looked at me and smiled and said, "Pink bats." And I like thought about that for a second. I went, "What? Pink bat? Oh." So in her mind, the fact that they had insulation was a source of heat. I was stunned
Okay.
at the degree of understanding. I would visit people's homes where they had a night store heater in the hallway, which was like a masonry block impregnated with electric coils. And it used to be in New Zealand, because so much of the power was hydro, you had very low rates at night when there was very little usage. So the night store heater would operate all night long, and it would be heating the hallway. And people would say, "Hey, open your bedroom door to the hallway, and the heat will kind of come in and heat your bedroom." And of course, as you exhaled in your bedroom, you would just have all this massive condensation on the perimeter wall and the windows from the moisture in the house as it got colder and colder outside. And it's like I was coming from the US where, you put your heaters underneath the windows. You don't put your heater in the center of the room. You put your heater under the windows. It heats the perimeter of the building, and you don't get condensation on the exterior walls. Uh, so it was a staggering adjustment to see just how differently the countries dealt with issues of tightness
For sure.
between the US and the much more forgiving environment here in Australia. So we're entering a time now where people are beginning to pay attention to tightening houses, but they're not paying attention to moisture management or other issues of indoor air quality.
Interesting.
So we're going to
Yeah.
have to go through this kind of painful period where we end up with tighter homes with problems, almost like what happened in the US way back. If you go back to the late 70s and early 80s, when we had building materials, particle board, and plywood using urea formaldehyde glues, and the stoichiometry was not very good, and the manufacturers weren't paying attention to the mixture. So you had lots and lots of unreacted formaldehyde, or you had excess formaldehyde. And that particular product, when it went into something like a mobile home that was suddenly manufactured to be tight, you had people whose eyes were irritating, and you can go into those mobile homes made with these materials and smell the formaldehyde. The levels were so high. The industry did a great job of regulating itself and reducing the level of emitted formaldehyde from the Waswood products that existed, and really address that problem. But the same parallel thing is happening where this tightening phenomenon that we're starting to go through, and will continue to go through without paying attention to sources and emissions and other concerns, is going to be a painful learning process for us, similar painful learning process.
Yeah.
We really cut across a lot of climate zones. The climate in
Yeah.
the northern part of the country is tropical, is totally tropical. They have monsoon season, and here
Yeah.
in Melbourne or even further south in Tasmania, it's much more temperate. So we have much more extremes than in the U.S. In the U.S., the tropical zone, I think, is limited to this tiny portion of southern Florida. Whereas here, it's like a huge chunk of the upper part of the country is in that climate zone. So we have a lot of challenges here in managing moisture and pollutants.
So do you think that's the big challenge for Australia then over the next few years, is starting to deal with moisture management in buildings? Is that going to be one of the big questions that need answering? Are there others?
I think the big challenge is tightening buildings, because if you look
Yeah.
at where energy loss occurs and the focus on sustainability, it's not about adding more insulation; it's about tightening. We have a community of people who do blower door testing on new buildings, and in particular, there's a lot of activity in commercial buildings. But normal residential construction and retrofitting of existing construction, everything was built really loose here. And stuff that was built 25 years ago is still single pane windows. I don't know when you guys would have had code requirements for double pane windows, but in the U.S., I don't know, was it 70s or something like that? I mean, it was a long,
Yeah.
long time ago that
Early
it was
80s at
mandatory
least. Yeah.
that to use double pane windows. Here, most of the housing stock that exists probably has single pane leaky windows. And we have really poor ventilation in bathrooms and kitchens. So we have to both do the tightening and simultaneously manage the exhausts and other factors that are going to, if they're not managed, cause big problems. So I think that's our big challenge going forward, is that there will be much more tightening by virtue of the construction code, the NCC, but they have to also pay attention to all of the problems that could arise when you tighten without managing moisture and pollutants.
Mm. And is ventilation a trade in of itself in Australia? Does it tend to fall in within the air conditioning industry, the electrical industry? Is it, are you seeing sufficient quality of ventilation systems appearing in buildings, or is there some work to do to try and
I
bolster that
think there's going to
sector?
be a big learning curve among the the residential HVAC people. They're going to have to understand all of these issues. Um, what they could get away with in a leaky building may be very different in a tight building, and even just the design. I live in a home that's a rental, where I don't think there's any wall insulation, and it's a very loose building. And we have massive solar gain in one portion of the building. The building was never zoned to manage the diversity of heat gain in the summertime, so the building does not cope well with the air conditioning doesn't cool the building, and then it's improperly zoned. And you know, recently, because the system was 25 years old and no longer working, it all got replaced. But it didn't get replaced in a coherent and appropriate manner. It got replaced in a way that made no sense. Which areas were zoned? There's three zones here with three separate heat pumps, basically, that are ducted, and it didn't get zoned in a way that made sense in terms of the loads in each area. And no attempt was even made to look at the loads and size the units for the loads that are present. Uh, and that just goes back to the fact that if the system works and it blows cold air or hot air, it's considered to be acceptable. It's working if it's blowing cold or hot air. Whether it's
Yeah.
controlling the temperature, or whether on a more sophisticated analysis, if you've got a room that has this extremely hot ceiling because there's not very much ceiling insulation, and it's got this extremely hot wall because the sun is beating down on it, it's not insulated. The radiant heating from those two surfaces in a small room may totally overwhelm the convective load. So you'd have to be blowing in air, to counteract that radiant heating component. That's a level of sophistication that doesn't exist at all. So, as we improve the housing stock, there's going to be a big educational jump for all the people who are putting in the systems. And also, they probably have been over designing the systems with the assumption that things are leaking and poorly insulated. And it's not necessarily good practice to end up with an over-designed system. You're going to have to adjust the system capacity to the existing load. So I think there'll be a bit of a educational challenge for them to address things in the future.
Yeah, and I'm not sure if it will be a double-edged sword or not, but we're certainly moving into a period of time where we can so effectively monitor the condition, at least at a basic level, of the indoor environment anywhere. The cost of low-cost sensors, certainly to measure temperature, relative humidity, CO2, the basics of building performance, is so ubiquitous now that that learning and that upskilling is going to have to happen within the context of being measured, and having to stand over the performance of the things that you design and install and put into buildings. And that's a very different place to where a lot of the rest of the world that has gone through that process over the last decade or so has been in, because most of that has been done blind. They haven't had to stand over the installed performance of these systems. So a lot of the conversations has been about the surprise of where these performance gaps appeared from, when academics did go in and look at buildings and go, oh, actually, we're not getting the performance of the heat pump that we expected. We're not getting air quality systems working the way we'd expect them to. You may not have to go through that because it's going to be live beaming out of every home. You'll see, that every smart
Yeah.
thermostat is pretty much capable of pulling in local weather data and telling you whether you're getting the moisture balance right in a building. Like, it'll be there on your phone telling you, and you'll be ringing up a contractor going, hey, this isn't working, you
Yeah.
know?
Well, and
Um,
we're really good in Australia and New Zealand in adopting things from other parts of the world and learning from other people's experience. So there isn't
Yeah.
an arrogance about doing things our own way. There is the opposite of that. There's a willingness to say, you know what, if someone else has already reinvented the wheel, let's just do it that way. So there's an
Yeah.
openness in that regard that I think is very positive and bodes well for how things, develop in the future.
Yeah, no, absolutely. I think we've covered loads of ground there, Brad. That's been absolutely brilliant. Look, thanks so much for spending the time talking to me today. You've been incredibly generous with your time. It was great to meet you last year, finally, after talking to you for so long in Copenhagen, I think it was, wasn't it, for
Yeah.
the AIVC summit. Look, I really appreciate you coming on the podcast. Thanks a million.
Great. Well, thanks for inviting me, and I enjoy watching it, and I'm glad that you're putting in the effort to talk with people in the industry. Thank you.
Brilliant. Thank you. Thanks for listening. Before you go, can I ask a favour? If you enjoyed the podcast and know someone else who might be interested, please spread the word and let's keep building this community. This podcast was brought to you in partnership with 21 Degrees, Lindab, ACO, Ultra Protect, and Imbiot. All great companies who share the vision of the podcast and are not here by accident. Your support of them helps their support of this podcast. Do check them out in the links and at airqualitymatters.net.